Yeah. So what do you get? And how do you get it?
Integral from 0 to 4.
Okay.
Square root x minus x plus 2.
Oops. Minus x plus 2.
Minus x, yeah, plus 2.
Okay.
dx.
Dx. Okay, and how do you get?
X.
There's more?
Yeah.
Okay, there's more. Great.
Minus. I'm probably wrong. Minus.
Good.
Minus x. Minus.
No, it's good.
Sorry.
Okay, so let me cut in here. So let's see. So you're saying, well, we've got this square root of x guy, right? Here's the square root of x, right?
Yeah.
And then we're going to subtract off, right? So, you know, let's say that here's your x, right? And the height here, right? The height here is y, right? That's the square root of x, right? And then the height here is the y value. Well, the y value is going to be x minus 2, right? X minus 2. So you have here something that's of height, right? The height here is, this is the height, right? Height, right? The height of your object. And then this dx, sometimes people think of this dx as like an infinitesimal width. Okay, so it's, you think of it as just sort of a, there's a rectangle here of a particular height, right? This is the height. And then there's this width dx here. And then you add up, this thing is a sum, right? A sum of the heights times the widths, and that gives you the area, right? If you go back to the Riemann sum idea of the integral, that's really what's going on here. We're taking these heights and multiplying by these widths, and then adding them all up. Okay. So yeah, so that's good. So this thing is the height, and this thing is the width. This thing is the width, right? And then you add up all of those guys from x equals 0 to 4, right? So that would give us this whole thing here, right? So it gives us a little bit more than what we wanted, right? Right? We have this thing, so we need to get rid of that thing. So let's subtract off something to subtract off that. Well, what's that? That would be the integral from, anyone want to say? From 0 to 1, right? 0 to 1 dx. And, you know, at each, when you fix each x, the height is this upper guy minus the lower guy. Well, who's the upper guy? The upper guy is the lower half of x minus x equals y squared, right? Right? So that is y, right? Here we got y equals plus or minus x, right? This is plus x, plus root x, plus or minus root x, right? This upper guy is the plus, this lower guy is the minus, right? So what do I write over here? Somebody tell me. Li Xiao. What do I write here?
In this area, there's a
So this first area is this thing here. This first area is this. The second area that we're going to subtract off, is this, right? And that will leave us with this area.
okay.
Yeah, and actually, before you came in, I made the rule: nobody use the phone in class. Okay. Nobody use the phone in class. If you use the phone in class, I'm going to take it away until the end of class. Okay, so put the phone away. Yeah, thank you. Yeah, you didn't hear it. That's fine. Right? Yeah. You weren't here, but I'm sort of, I don't want to see any more thumbs in class. Okay.
X minus 2 minus
X minus 2, that's the lower guy. That's this line, right?
yeah
X minus 2 minus what?
minus Z1.
Minus, X minus 2 is actually this line here, right? So let me blow it up. Right here we have this line coming in, right? 0, 1. This line is y equals, this curve is y equals negative root x. This line is y equals x minus 2, right? So how do you get this area is what we're asking right now. How do you get this area? Well, what's the height? Again, you take these tiny rectangles, right? So what's the height of the rectangle? Well, you take the upper value minus the lower value, right? So the upper value is, somebody say it please, minus the square root of x, right? And then you subtract off the lower value, which is x minus 2, right? Okay. Everyone okay with that? Bangdi, are you okay with it? Are you really? Are you lying? No, you're okay.
I don't use X.
You-
I use Y.
Okay, very good. That's yeah, actually.
You
So
don't need
you don't need two integrals in that,
Yeah.
right? You don't need two integrals, right? Actually, that's cleaner. So yeah. So tell me how you did it.
First, I calculate the range, which is 1 to -1, and then I substitute the x into y, and then I get y squared minus 2 minus y.
Okay. So for each y, right, you have to look at the difference in x values, right? So the x value here. We fix the y, right?
Actually, I changed I didn't draw the image like that. I actually
You rotated it
Yeah.
and then did it that way. Well, let's not rotate it.
easy to see.
Yeah, it's easier to see, but let's just keep it this way, just for practice. Okay, if you don't mind. Okay. So right. So if we fix the y here, then this x value is going to be y plus 2, right? Right. Is that clear? Right. This line is y equals. Sorry. This line is x minus y equals 2, right? So when you fix the y, then the x is going to. The x is going to be y plus 2, right? Anyone see that? The x value is y plus 2. And then over here, right, for the fixed y, x is y squared, right? X is y squared. Okay. So then, what's the length of this thing? Right. Again, you're thinking in terms of tiny rectangles. Right. What's the length of this tiny rectangle? Wang Di, what's the length of it?
2 plus 1
Minus
x
y squared.
y squared.
Y squared, right? So you get y plus 2 minus y squared, right? And then you have this dy. The dy is the infinitesimal height. Okay. Everyone okay with that? Okay. So either way, that's good. You're going to get an integral that gives you the answer. Okay. And then you just use your techniques of integration. You use some u substitution or something to. You don't even need u substitution. You just integrate this and you get the answer. Okay. 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 How about, so I'm going to give you, I'm just going to give you a lot of things to try. Okay, so here's one. F of x is negative 2x plus 4. G of x is x squared minus 9x plus 10. Okay, so the picture is that, what's the picture? You have a parabola going down, right? You have a parabola going up, and you have a parabola going down. Okay, and I'd like you to find the area between the two parabolae. Okay, turn to somebody nearby and make friends with them. I just want you to set up the integral. You don't have to evaluate it. We already done enough evaluation practice last week. Just set up. Okay, I really want you to talk with each other. Those of you who are not saying anything, please talk to somebody nearby. Wang Qingchang and Li Xiao, please talk. Wang Di, talk to Taoran. I don't know. I don't know. You have to, Chen Renjiao, Chen Renhao, we talk with the people. Talk with An Qingyu and An Qingyu. Talk also. Please include Chen Renhao in your group. Thank you. Thank you. Okay, so who would like to tell me how to do it? Who would like to say how to do it? Lisa, do you want to try? Would you like to say? How do you do it?
Calculate the points to functions.
That's right. Calculate where the two graphs graphs intersect, right? So what do? You set these things equal to each other, right? Right. You get. What do you get? X minus 2, X minus 1. Right, and so between 1 and 2, right? 1 and 2, and then what do you do? And then what is it?
Use the upper function subtract the lower one.
Right, so you take the upper guy, and you subtract off. Oops. And you subtract off the lower guy. And then it's an easy integral from there. Okay. So it's pretty easy. Here's just one last one to do. One of the sort. So want the area of the region.
Excuse me.
Yes.
Which function is the upper one?
Which function is the upper one? Oh, I'm sorry, it's backwards.
Yeah.
Sorry. Sorry. Yeah, this one is the upper one. This one is the lower. Thank you. Okay. Area of the region in quadrant 1. When people say quadrant 1, they mean this quadrant. 1, 2, 3, 4. Area of the region quadrant 1 bounded by the x-axis, y equals x squared over 3, and x squared plus y squared equals 4. Okay. So take 2 minutes, 2 or 3 minutes, and set up the integral, please. Okay, turn to somebody nearby and say what you did. Okay, would somebody like to say how they did it? Anjini, how about you? Not today? What did you say? What I heard was not today. What? I'll give you a few more minutes. Sure. Okay, take 1 more minute, everybody. We need a little bit more time. Okay, it sounds like people are about done. Anjini, do you want to try or?
There are also
Zero to root 3. Okay. Okay. So maybe can you just tell me tell me how things look like? What's the picture here? So we have we have a circle, right? This thing is a circle of radius 2, right? And then we have this parabola, right? Y equals x squared over 3, and it goes up like this. Right, and so we're asking, what's the area of this region, right? Okay, and so how do you figure it out? that's right. Right, you need to, right, you know, maybe the way to, you know that you need to have both of these equations going at the same time, right? So, right. So can somebody tell me how do you find the point of intersection? Chen Wen Hao.
So, that square was really equal to 4 minus x squared.
Right. So you can use the y. You have to be y has to be x squared over 3. X squared plus y squared has to be equal to 4, right? So the two together is maybe substituting this into here, right? You get that x squared plus y squared equals 4, right? Right. So you get x squared plus x to the 4th over 9 equals 4. Okay. Right. And what do you do with that? Chen Wen Hao.
Uh,